Class Kick, pay that notebook that says notebook reference section, go to that Pythagorean theorem notebook, and these are on page 4. So there's literally a gazillion real life ways that you really do actually use Pythagorean theorem. And today I'm going to walk you through just a series of some that really are real life based and a couple that, like this first one right here, that honest and truly isn't all that great. It's literally just that the man, I guarantee you will probably see a problem like this on your ACT because they love these problems that involve like leaning a ladder up against a building for some reason. They like really enjoy word problems like that. The good news is they all pretty much have the same format, okay? So you've got a ladder against the top of a building. I just want to make sure you see how the diagram is kind of like laid out and everything. So you got a building here. Don't be jealous of my amazing artistic strengths here. And there is a ladder leaning up against the building. Okay, so there's my ladder. So, all right, so that ladder is 37 feet. So sometimes what confuses people is they're not sure if the 37 should be that part or the building. So when they talk about the length of the ladder, they're talking about that 37 right there. So it also tells you that the top, so it's leaning against the top of the building and that the bottom of the ladder, okay, so the bottom of the ladder is 22 feet from the bottom of the building. So look at what that little problem makes. It makes a little imaginary right triangle. And it's asking how tall is the building. So you're trying to figure out how tall is that building if you've got that. So you guys know what to do. This part I'm going to do pretty quickly because I think the point of this lesson is really just for you to know how to set them up, right? So I'm going to do this part pretty quickly. So does it matter what I substitute in there for A and B? Nope. So I'm just going to put x squared in for A, and I'm going to put 22 squared in for B. But 37 has to be your hypotenuse because that is the longest side. I've gone ahead and, for the sake of time, done our calculations already. So you'll have x squared, 22 squared is 484. And then 37 squared is 1369. And then you guys know from yesterday, when you're solving for the leg, you just need to, subtract on both sides. So x to the second power is equal to 885. And lucky you, when it says round to the nearest tenth, all you have to do is plop it into the calculator. You don't even have to simplify the radical. So the square root of 885 is roughly, if you're rounding it to the nearest tenth, that is going to give you approximately, that's what my little curly Q thing says, 29.7 feet. So all it is a Pythagorean theorem problem in disguise. 100% you will see something like that in your future, especially on K-Prep. They love stuff like that. Or I'm sorry, when I was teaching middle school last time, it was called K-Prep. Now it's called KSA, but they love problems like that on Pythagorean theorem. All right, so the second type that you might see is something like this. So you've got a rectangle. So go ahead and draw yourself a rectangle, hopefully better than the one that I just did. And the area is 380 square units. And it tells you that the length is 20. Some people argue that that's length or that's length. It really doesn't matter. You're going to get the same answer. I would argue that that's the length. Now, it didn't ask you to find this. It's asking you to find the length of the diagonal. Okay? You will do this a bunch in high school geometry next year, where they'll give you the dimensions, area, or what have you of a shape. So right now, though, my problem is that I don't know how wide it is. But lucky for me, I know that you find the area of a rectangle by multiplying the length times the width, right? So if I do 380 and divide it by 20, because that's how long it is, that tells me, bless you, that my width is 19. Correct. Exactly. Okay, so I know that's going to be 19. So then, once again, you're just doing Pythagorean theorem. You're going to do your a squared plus your b squared equals your c squared. And again, this part I'm going to do pretty quickly. This time, because we're solving for the diagonal, that means we're solving for the hypotenuse this time. I'm going to substitute 20 in for a and 19 in for b. For no particular reason, I could have done 19 for A and 20 for B. Doesn't matter which one. So that will give me 400 plus 361 after I square them, and 761. Last but not least, we need to find the square root. Lucky for you, again, it says round to the nearest tenth. So all you got to do is plop it into the calculator, and that will roughly be 27.6. So I'm going to put this approximately over here. And we'll just say units. So for A, we've got, or for the first one, we've got that. And then so all you got to do is plop it in the calculator. I figure for today that having to set up the word problem is asking you to do enough work. So I just want to make sure that I make it easy on you, so no simplifying radicals for your solutions today. Anybody not okay if I, oh, yes, yeah.
Can you simplify it like a decimal?
That's a great question, and no, because that decimal is really just an estimate, right? So you can't really, like, you're already kind of off, so you don't want to, like, simplify what's already off, like, even more. Does that make sense? Okay, so, yep, but good news is you can just plop it in the calculator. All right, so there's a couple of terms for the next one that I want to make sure that you're aware of that you might not have. So first of all, we're going to draw an isosceles triangle. What can you tell me about an isosceles triangle? Do we remember about, what do you remember about them?
It has two equal sides on the right and the left, and
Yep.
then the one at the bottom is shortest.
Correct. So I've got two equal sides. An altitude, in case you haven't heard that term, an altitude it means a lot of things like outside of school, but in math class, an altitude just refers to a straight line, a vertical line that cuts the triangle in half. That should be in half. Please ignore my ridiculously crappy drawing. And because, ooh, yeah, that's really bad. That didn't even look close to halfway. Sorry, guys. Yeah. Back when I actually had to teach geometry, I had to like pre-do all my shapes because I like literally can't even draw a triangle. Okay, so what does that altitude do? Well, that altitude cuts it in half and makes like a right triangle right here, right? So it says the length of the altitude is 11 inches. So you know that height of the triangle is 11 inches. And it tells you that the length of the base, so where's the base of the triangle? Where's the base of like a statue? It's at the bottom, right? So same thing. So that means that the base, the bottom is 6. And it's asking you to find the perimeter. So you don't have the length of either of those two slanted sides in order to get the perimeter. But that altitude has cut it in half and made an imaginary right triangle, right? So I'm going to use that to solve for the slanted side. And because Ren already told me those two the sides are going to be congruent. So once you find one, you know how long the other one is, so you can just add them together for the perimeter. This is the most common mistake that I see students make with this problem. Don't write what I'm getting ready to write in red. You can go ahead and write the formula, but I'm getting ready to do something wrong because I want to warn you. about a mistake that I see kids make, even bright kids like you. I see them make this mistake a lot on a word problem like this. So we do know that C is going to be that slanted side, so you can go ahead and write that. And we know that I'm going to make A 11 inches. Here is where we have a tendency to go wrong. Bless you. Okay, so you know it's wrong because I wrote it in red. What specifically is wrong with that? Yeah, Tatum?
Because that's like the two together.
Correct. So that's the two triangles together, right? Because that's the entire base. Bless you. So if I just want to treat this as a right triangle, instead of 6 squared, I'm going to cut it in half to get 3 squared. Exactly. So that's going to give me 3 because I had to cut it in half. The entire base of the triangle was 6. So we all know what to do at this point. You know you need to do 121 plus 9. Let me not do such a bad job squishing that together. So I got 121 plus 9 equals x squared. And we've got 130, which we know we need to take the square root of. And once again, this is just asking us to round to the nearest tenth. So all we have to do, somebody correct me if I'm wrong, I think it didn't end up being like 11.4? If you put it in the calculator, 11.4 inches. Now, am I done?
No.
This is also where kids have a tendency to go wrong. What did I just find? What does that 11.4 represent?
The
X.
X.
What does the problem ask me for? Perimeter. Exactly. So I'm not done. Don't do all the hard work and then be like, okay, I'm done, because I'm not done, right? So now that I know that that's 11.4, what I need to do now is do 11.4 plus 11.4 plus 6. And that will actually give me my true perimeter, 28.8-ish inches. So on these multi-step problems, that's where people, like, the actual math isn't hard. I could tell a bunch of you guys worked ahead. There's a lot of little places that people have a tendency to go wrong. And so I want to make sure you don't make those like little mistakes. If it asks you for the perimeter, make sure you finish the whole thing out. Okay, so the last one, I'm going to skip the one with the area for now, and I'm going to go to this last one on the right because we're a little bit short on time. So we'll come back to the one for the area tomorrow. And so for this one, it's asking you to find x. But why can't you just do Pythagorean theorem right now? Why can't I just find it the way it is? Do I have two sides? No, I don't, right? So what you're going to have to do is you're going to have to do Pythagorean theorem on the other triangle to get that green side, so that then we can use the green side to get the pink side. So we'll have to start with a squared plus b squared equals c squared. This part I'm going to do quickly because I know you guys have it. So this will be 16 plus 16, which will be 32. And you guys know you need to do, now, for what I would do for now, guys, because it's going to make your calculations easier. If you want to go ahead and estimate it to the nearest tenth, you can, but it's going to be easier for you and less work if you leave it as a radical for now. So I'm actually going to leave that as a radical 32 first. And why is that easier? Well, because now when I do a squared plus b squared equals c squared in the second part of my triangle, what do you get if you do radical 32 times radical 32? You just get 32, right? Because whenever you multiply the square root of something by itself twice, the square root and the square cancel each other out. So that's really less work for you to go ahead and just do it that way. So, I'm sorry. And then I need my C, which of course the C is 10. So we should have our 100 right there. So I've got x squared plus, and again, 32, or radical 32 times radical 32 just gets you 32. Subtract 32. I'm doing this part pretty quickly because I know you guys know what to do. 68. And you can just plop, oh, that's x squared, my bad. And you can just plop that into the calculator. And radical 68 ends up being roughly 8.2, if I'm not mistaken. And there's no units here because it doesn't give you any. So those are all of the two-dimensional Pythagorean theorem problems you're going to have today on your classwork assignment. So hopefully you should probably have time to get finished with this assignment still. We'll play it by ear and see if we have a hard time, especially since all you have to do is use the calculator to round today. This probably won't be as much trouble. Yes, Dia?
Could you scroll up to the ladder problem I missed it?
To the left, yep. You're welcome. All right, so there is a Delta Math assignment that we'll take the rest of class to work on. And again, I'll play it by ear. I may need to give you a little bit of extra time tomorrow, depending on how you do. We'll take a look at that shortly. Anybody need me to like keep it out like this? Okay. You're very welcome. I know we've got Asha, yell at me when you're done with the ladder problem, please, so that I can scroll back, make the rest of it, zoom in on the rest.
I have a question.
Oh, yes, dear.
So, where did you get the...
I wasn't given two sides of the right triangle, so that's why I had to use the green side to do Pythagorean theorem to find the hypotenuse of the triangle on the right. And then once I got the square root of 32 for that length, I used Pythagorean theorem over here and used that to find the missing leg. Because I had on the other triangle, now that I knew that long piece, or that part that separates it, is square root of 32, and I know that the hypotenuse was 10, then I could use that to